Hello, Jake. Since you've missed class today, we're going to just take a look through a couple of things dealing with our cathode rays. Now, it's important to remember that it was only the charge to mass ratio which Thomson discovered. He did not know the mass of an electron. He did not know the charge of an electron. He just was able to discover the charge to mass ratio. But the results from this were much bigger than any atom he had before. Now, he did this by, first of all, taking cathode rays, which were negative, and notice that they deflected with the magnetic field, right? So there would be a magnetic field here, and that kept it moving in a circle, so you could say that mv squared over r is equal to qvb. The question then becomes, well, how do we figure out what the speed of the electron is? And for that, before actually entering into the beam, we put it through a magnetic and electric field that work perpendicular to each other. And because you would know the electric and magnetic fields here that would cause this to move undeflected, you can say that in this area, the electric and magnetic field are equal and opposite, and use that to find the velocity. So let's take a look at some of these mathematical examples. Taking a look. Charged particles traveling horizontally. We've been given a velocity that they've been moving, so we don't need to calculate that. Magnetic field of 7.71 teslas, and how much it is deflected. We're looking for the charge to mass ratio. It is the magnetic force that is keeping this in a circle. So QVB is equal to mv squared over r. But the thing is, we're looking for the charge to mass ratio. We're looking for Q over M, charge to mass. One of the velocities cancels out, and with a little bit of manipulation, we wind up with velocities equal to RB. So we're going to plug in these particular numbers. Q over M is equal to 3.60 times 10 to the 6, all divided by 0.71, and 9.5 times 10 to the negative 2, or 9.5 centimeters. Pause the video, check your answer, and see if it matches mine, which is 5.34 times 10 to the 7 coulombs per kilogram is the standard units that would be here in terms of a charge to mass ratio. All right, let's take a look at a second example here. This time we want to know what the speed of the electron is. It is traveling undeflected through a beam caused by a magnetic force and an electric force. These forces must be equal and opposite for this electron beam to travel through undeflected. Okay, so we know this is QVB. Force electric is QE. The charges conveniently cancel out, which leaves us with an electric field divided by the magnetic field. So we're just going to take those numbers, the electric field being 6.30 times 10 to the 3 newtons per coulomb, divided by 0.711 times 10 to the negative 3 teslas. I know that is poor scientific notation. However, we still wind up with a velocity of 8.86 times 10 to the 6 meters per second. Verify that answer. Make sure that it matches mine. Okay, in our third example, we are looking for the kinetic energy of an electron. It's traveling through a magnetic field and deflected with a radius of basically 3.7 millimeters. This is a very tight circle. Well, you've got a magnetic force that is keeping this thing moving in a circle, so QVB is equal to mv squared over r. And in this case, we're looking for the velocity first in order to find the kinetic energy. One of the velocities cancels out, so QBR over m is equal to that velocity. When you plug in the numbers for an electron, that's 1.6 times 10 to the negative 19 coulombs of charge, with a magnetic field of 7.20 times 10 to the negative 2 Teslas, and a radius of 3.70 times 10 to the negative 3, all divided by the mass of an electron, which is 9.11 times 10 to the negative 31 kilograms. You find that the velocity, and you'll want to check this, is 4.678 times 10 to the 7 meters per second. And plugging that in for kinetic energy, which is 1/2 mv squared, given the mass and the velocity we've already got using our calculator answer, kinetic energy should be 9.97 times 10 to the negative 16 joules. Again, verify that answer, pause the video, type it in your calculator, and verify. All right, lastly, we are going to take a look at this multiple choice question from a diploma exam. We've got a negatively charged sphere. It's coming through and being deflected upwards, right, in region Y. So this is where it will accelerate in region X. This is where it's bending in region Y. And really all we're asked is about the free body diagram that shows the forces acting on the sphere in region Y. Now, in region Y, obviously you're going to have a force of gravity, and a negatively charged sphere is going to have a force exerted on it up towards the positive plate. So your free body diagram should match these, and we take a look at our options, and you should find that the correct answer is in fact B. Okay, so those are the questions. Hopefully that helps, and we will see you in class soon.